We think we know what the laws of nature are, pretty much, okay? But we also know that they're not completely consistent. So there must be something not quite right. But whatever is not quite right is very small in the sort of general scheme of things. So one way of attacking this is to go looking at extreme conditions at things like the Large Hadron Collider at CERN, but another way of doing it is to do very, very high precision measurements and look for very, very small discrepancies between your experiment and your theory. And it's a way of probing the unknown that this building is designed to enable.
So we thought very carefully about the cladding for the building in this part of Oxford, and there's influences taken from Keble College Chapel, which is just over the road, and other historic buildings within this part of Oxford. But clearly the cladding is a contemporary interpretation, and it uses contemporary materials to position this building as a new science building right at the heart of the science area for Oxford.
I think it's extremely important that this building is positioned such that it provides interaction between the various scientific disciplines, because quite a lot of the discoveries that are taking place within science at the moment are happening at the fuzzy areas between the different sciences.
One of the fantastic things about this building is that it brings people together. It brings theoreticians together with experimentalists in a fantastic space where they can interact with each other and discuss the challenges, but also the opportunity of collaborating.
It's a symbiotic thing. If you just do experiment, you just collect facts. If you just do theory, you can very easily end up just writing down mathematics, which has got nothing to do with the description of the real world. You need both working closely together to understand nature.
Blackboards feature heavily throughout this building, so it's the main writing surface that physicists use. So whilst they're developing a quantum computer, they're also using blackboards as their main writing tool. So people circulating around the atrium are able to overhear conversations, which enables for collaborations that may not be the most obvious and may not happen otherwise. I think getting our heads around these extremely onerous technical performance requirements was challenging at first, and still is. So understanding why the minutest movement or change in temperature can affect the experiments has translated throughout the whole design.
The scientific problems that we're interested in are the really tough ones, the ones that really matter, the ones that are on the cutting edge of science globally. So we're aiming to be one of the world's leading science departments. And we're working on the toughest science problems at the moment that physicists can make a contribution to.